You flip a switch on your stove, and blue flame appears instantly. You turn a dial and your house fills with heat within minutes. Somewhere, a power plant is burning something dark and ancient so that your phone charger works. So your lights turn on. So your shower runs hot. You never think about where that heat actually comes from. You just expect it, the way you expect gravity to keep working. But somewhere between 400,000 years ago and about 1,000 years ago, a human being looked at a black rock, or the leftover crust of a burned-out fire, and made a discovery that would eventually power entire civilizations. They had no idea what they were starting. So here's the question. Long before anyone understood chemistry, before anyone knew what carbon even was, how did ancient humans figure out that certain rocks and certain burned wood could burn hotter, longer, and more usefully than ordinary fire? And how did that discovery end up reshaping human history twice? Once quietly, and once so loudly it built the modern world. Let's start with charcoal, because charcoal almost certainly came first. And it came from something incredibly simple, a regular wood fire, left to smolder and burn down under limited air. Here's what nobody tells you about ordinary campfires. When wood burns in a fire that's short on oxygen, buried under ash, packed too tightly, or covered by fallen debris, it doesn't fully combust into ash and smoke. Instead, it partially burns, driving off water and volatile gases, and leaves behind something new. A blackened, brittle, lightweight version of the original wood. That's charcoal. And any human tending fire for even a few thousand years, which they absolutely were, would have eventually noticed leftover chunks that looked different from regular burned wood. Chunks that reignited faster, burned hotter, and produced less smoke. 2. Archaeologists have found charcoal residue at Wonderwerk Cave in South Africa, dating back roughly 1 million years. Evidence tied to the earliest known controlled fire use. That means the raw material for this discovery, the accidental byproduct, was sitting in ancient hearths for an almost incomprehensible stretch of time before anyone did anything deliberate with it. Here's the part that actually matters, though. Noticing charcoal is one thing. Understanding what it could do is an entirely different leap. And that leap seems to have happened specifically around metalworking. Think about that for a second. Regular wood fire burns at somewhere around 600 to 800 degrees Celsius. That's hot enough to cook meat, harden a spear tip, keep predators away. It is nowhere near hot enough to melt copper, which requires temperatures above 1,000 degrees Celsius. Charcoal, because it's already had its water and volatile compounds burned away, burns cleaner and significantly hotter than raw wood, especially when air is forced into it. Archaeological evidence from sites in the Balkans, including Belovode in modern-day Serbia, shows copper smelting dating back roughly 7,000 years, right around 5,000 BCE. That timing is not a coincidence. Someone, somewhere, figured out that if you burned wood down into this dense black material first, and then burned that material with a bit of forced air, you could reach temperatures that ordinary fire simply could not touch. That single discovery didn't just give humans a better fuel, it gave them the Bronze Age. Now here's where it gets genuinely strange. Because coal is a completely different story. And it starts not with fire at all, but with rocks. Coal doesn't look like fuel. It looks like a black stone. You would have to be remarkably curious, or remarkably desperate, to look at a lump of shiny black rock lying on the ground and think, I wonder if that burns. But it turns out ancient humans were both. 3. The earliest confirmed evidence of coal use comes from Neolithic China, specifically the Shenyang region, where archaeologists have found coal used for both fuel and ornamental carving, dating back roughly 6,000 to 7,000 years. That's an extraordinary detail, because it tells you the first people to use coal weren't thinking about industrial fuel at all. They were carving it like they'd carve stone or bone, and only afterward, possibly by accident, someone realized the scraps and shavings caught fire far more easily than expected. In Britain, archaeologists have found evidence of coal being burned at Bronze Age and Roman sites, including cremation and heating contexts, with coal specifically identified in Roman-era hearths across sites in Wales and northern England. The Romans, notably, mostly used it for industrial and heating purposes rather than everyday cooking, Likely because coal smoke is genuinely unpleasant and somewhat toxic in enclosed spaces without proper ventilation. Here's what doesn't make sense until you think about it. Coal was sitting exposed on riverbanks, cliff faces, and eroded hillsides for as long as humans existed. Coal seams, where the rock is close enough to the surface to be visible, occur naturally across parts of Europe, Asia, and North America. Someone eventually would have thrown a stray lump into a fire, either by accident or out of pure curiosity, and watched something unexpected happen. There's also a piece of this story that gets almost no attention, and it involves indigenous peoples of North America. Archaeological evidence from Hopi communities in the American Southwest shows coal use dating back centuries before European contact, both for heating and, remarkably, for firing pottery at higher and more controlled temperatures than wood fire alone could reliably produce. This wasn't accidental discovery repeated once. 4. This was independent parallel discovery happening in multiple places around the world by people with zero contact with each other, all arriving at roughly the same conclusion. That black rock, under the right conditions, burns better than wood. When something gets discovered independently that many times across that many cultures, it stops looking like luck. It starts looking like an inevitability, waiting in the ground the whole time. So why didn't coal take over immediately? Why did it take thousands of years, in most places, for coal to go from occasional curiosity to society-defining fuel? The honest answer is smell, smoke, and access. Coal, when burned in an open hearth without proper airflow, produces heavy, choking, sulfur-tinged smoke that is genuinely unpleasant to breathe, especially compared to wood smoke. For most of human history, if you had wood nearby, you burned wood. Wood was familiar, predictable, and didn't turn your lungs and your ceiling black. Coal only became necessary when wood stopped being convenient, and that moment arrived dramatically in medieval England. By the 13th century, England's forests were being stripped at an alarming rate, consumed by shipbuilding, construction, and the simple growing fuel demands of an expanding population. Wood prices climbed. Access to forests became restricted by nobility and landowners. And slowly, reluctantly, English cities like London began turning to what they previously considered a dirty, undesirable fallback. Sea coal, so named because it was often gathered from coastal outcrops and transported by ship along the English coastline. Historical records from London in the 1200s already described complaints about the acrid smell of coal smoke filling the city. And by 1306, King Edward I had issued a proclamation attempting to restrict coal burning in London, specifically because of the smoke problem. Think about that. 5. Coal pollution complaints in London predate the Industrial Revolution by roughly 500 years. This wasn't a modern problem. It was ancient, and humans knew it, and they burned coal anyway, because the alternative was freezing. There's a genuinely fascinating parallel discovery buried inside all of this, and it's about coke, which is essentially coal's answer to charcoal. Just as ancient humans learned to burn wood down into a pure, hotter burning material, someone eventually figured out you could do almost the exact same thing to coal. Heat it slowly, with limited air, drive off the impurities and gases, and you're left with a denser, hotter, cleaner burning fuel. In England, this process became industrially significant by the early 1700s, when Abraham Darby began using coke instead of charcoal to smelt iron at Coalbrookdale, dramatically increasing how much iron could be produced without stripping entire forests bare in the process. But here's the thing that connects everything back to the very beginning of this video. That transformation, wood into charcoal, coal into coke, is the exact same basic chemical principle discovered by accident in a smoldering fire almost 1 million years earlier. Limit the air, control the burn, and you concentrate the fuel into something far more powerful than what you started with. Ancient humans figured out this principle with wood long before they had any concept of chemistry, and thousands of years later, other humans applied the identical logic to rock pulled straight out of the ground. What's genuinely humbling about this entire story is how much of it was never planned. Nobody set out to discover metallurgy. Nobody woke up one morning intending to invent the fuel source that would eventually power steam engines, factories, and the entire industrial world. Someone was just tending a fire, noticed something odd left behind in the ash, and paid enough attention to remember it. 6. Someone else picked up a strange black rock, maybe out of boredom, maybe trying to carve it into a bead, and happened to drop a fragment near a flame. These weren't geniuses executing a plan. They were ordinary people, being observant in a world that rewarded observation with survival, and occasionally with an accidental discovery that would outlive them by tens of thousands of years. So let's pull this all the way back together. Ancient humans faced two separate problems buried inside the same basic need for heat. Regular wood fire wasn't hot enough to melt metal, and the solution turned out to be sitting in their own ash pits. The entire time, waiting to be noticed, wood wasn't always available, and the solution turned out to be lying exposed on riverbanks and hillsides across multiple continents, discovered independently by people who never met each other. Charcoal gave humanity the Bronze Age. Coal, thousands of years later, gave humanity the tools to strip iron from rock at massive scale, and eventually power the machines that built the modern world. Two black substances, one grown from fire itself, one pulled from ancient compressed forests, buried underground for hundreds of millions of years, and both discovered essentially the same way. Curiosity, accident, and someone paying just enough attention to notice that this burns differently than that. And now think about your own life for a second. Every time you turn on a light, somewhere, electricity is likely still being generated by burning coal, the same black rock a Neolithic farmer in ancient China once picked up and started carving without any idea what it was capable of. Every steel beam holding up, every building you've passed ever walked into traces its existence back to charcoal-fueled furnaces first figured out by someone standing over a Bronze Age fire pit, watching embers glow, just a little too hot to be ordinary. You didn't invent any of this. 7. You inherited it, quietly, completely, without ever having to think about the millions of small moments of human curiosity stacked one on top of another to get you here. Somewhere, thousands of years ago, someone reached into cold ash, picked up a piece of blackened wood, and decided it was worth keeping. That single unremarkable decision is the reason your lights turn on tonight.